Hello, and today we've got a little sample. What this sample does I'll show you in a second, and then I'll explain how it works. So press the play button to run Unity, and what we have here, you saw this character. I'll do that again. I'll press play and it's raising its hand. We'll see that in a second when it loads. And what this is a skeleton. See, there it is raising its hand. Now I'm pressing the control button on the keyboard and moving the mouse. You will see that where I'm looking is changing because I am simulating being a VR headset, and you will see the character, it is moving its head and there's no restrictions in where it can walk or where it can look even. And so I'm stopping doing that, and we'll have a look at a few things on how I managed to do that. So the first thing is I've got a character. So Unity and the others use a skeletal based system consisting of bones. You can see a bone here. There's 1, 2, 3, 4, 5 bones, and they're connected to a spine, much like anyone else, a human. And attached to the spine is the mesh, and attached to the mesh is the skin as such, which is this UV mapping. Now I have put this within my project and put on the UV map, and I've created what's called a high definition based renderer. There's the lightweight rendering protocol, which is the basic, and then when we have recently renamed to the universal rendering pipeline, and then you've got the high definition rendering pipeline. And this high level definition pipeline, it's for high-end devices, but you don't have to have all the features enabled. And what we have down here is the character itself, and we've got the bones associated with it, so much like a skeleton. And when we talk about kinematics, if I'm pronouncing it right, it's talking about the bone system. So in our scene we've got our character. Within the character we have armature, which is a skeleton. We have the character skin itself. We have a lamp so we can actually see the thing, and then we have this pool that I'm just left in here. We have the camera rig. This is OVR for oculus rigging, so this is the camera. I could replace that with a first person camera instead. We have a prefab, which these are prefabricated. These are just objects that exist. I'm not really using them yet, so I could just hide these if I wanted, and a possible timer. And if I have a look at this particular object, we have the OVR camera rig, the tracking space, which consists of a number of different trackers. And remember, these 3D devices have different capabilities. We have eye tracking, and we have hand tracking in some of them. So some of the more expensive devices like the HoloLens, I think, and the Vive Pro currently have eye tracking, and the Oculus Quest doesn't, but it's on the roadmap, I believe, for the next thing that could be added. And within the camera rig we have scripts associated with it. We've got the OVR camera rig and the OVR manager, and then we have the headset emulator. So we can do, the idea is you can shift it up and down when you saw play, that I could do with the mouse, but there was a restriction where it wasn't working, which I'll show you how that works shortly and how I got around the problem. And I'll also show you how I managed to adjust the animation here. So if I have a look at the animation that's attached to the skeleton, so let me go to the scene, let me go to the character, let me select. So we've selected the character. We have a number of things like the animation here that's associated with it. an animator, and then on top of this we have, this is the animation that's associated with it, and within here we have inverse kinematics pass, which means that I've enabled an event that I can programmatically control our character, which is a lot of fun. But when I first tried to run this scene, it didn't work. Why not? It didn't run because I had to do a particular override on here. So in the OVR plugin, if I were to plug in the Oculus Quest, I would be able to hold down Control and Shift and move it around just on the headset, and it would work. But when I unplugged the Oculus, it did not detect it. And this is looking for the Oculus Quest to be initialized, which it wasn't. So I've instead changed this to return to true, because this uses reflection all the way, which is great. So then I was able to not have the Oculus Quest plugged in to do this mirroring effect that I wanted to do. The next interesting thing, which you saw from the character, it lifted up its arm, and it also allowed me to control the head. So what I've done is I've got a number of controls. So for example, the animator, attached to the animator are the bones of the character, and there are, I think, 14 bones that we need to play around with in order to be a human. So all I'm caring about is the right hand, and connected to the right hand are the other bones. So if I shift this hand, all the other connections are obviously connected, and that's what inverse kinematics is. It does the opposite. It solves via maths how these things are all connected, because I want to make sure the shoulder stays where it is. The next bit we see here, I am doing an animation. So with animations, when you're doing it in a programmatic way, we've got a start time, we have a calculation distance. In this case, I am calculating from the arm. The arm is starting actually down by the hip where you see my mouse is, and then over time it will be shifting up to point to the pole, which is this bit here. So if I zoom in here, it starts here, that's when I press play, and then the hand reaches for it wherever it is. So if I move this out the way, it would reach for it. So, and then we've got the speed here itself. This should be replaced with an actual time dependent delay. So if we were running at 10,000 frames a second, it would instantly complete. If we were running at 1 frame a second, it would take 10,000 years. It would have to be changed so it covered a certain amount of distance in a certain amount of time. So I have this update method, this OVR manager. We have the head pose relative offset rotation. That basically means wherever the camera is, wherever it's looking, get that setting, because I'm emulating it at the moment. It's being controlled by this emulation script, and I am getting that value off the manager itself. Then I am doubling its value. That's just to exaggerate it, and then times by -1 to looking another direction. So when I am looking left and right, it's doing pretty much mirroring on the left and right, and then it's looking the correct way up and down, but I can mirror it so it would do the exact opposite. And then finally, when it comes to the actual animation, when I tick that box around inverse kinematics, we have bone rotation. So this is giving me the value that I have set over here, and what this does is that when I am trying to adjust it, if I had the headset on, which I will at some time, it will copy where I am looking, which will be good if you were in a virtual environment, for example. Then the next thing is, how did we do the raising of the hand? So currently we have the amount of speed times time, which is a classic physics formula to work out how much distance should be covered, and then working out a fraction of the journey depending on the speed to then create a position of where it should be from where it started to where it should be finishing, from that fraction to position. Then we have the fraction, and then this is the destination, and this is how far I should travel. So if I wanted to make this more accurate, to say take 2 seconds, then I would be trying to calculate how much distance it should have traveled within 2 seconds instead of this speed variable, because the speed variable does not give us accurate enough control to be useful, because we do not want it to finish too early and we don't want it to finish too late. We normally, as human beings, we talk in seconds and minutes for animations to be finished. And interestingly enough, I can also, if I had other bone systems, or sorry, other skins, instead of having this, I instead could change it from this cuddly character into a monster, into whatever the case, and that would allow me to have different characters. But then I could also find other animations to have walking animations, reaching animations. So instead of being straight reaching up for something, it could be a bit more realistic along the way, because each one of the movements could be more calculated, which is more of a content problem than doing this programmatically, because these headsets, they record your hand movements, they do not record your elbow movements, whether they're in or out or whatever the case. So it's not fully natural just pushing the hand to one place, because it's obviously all connected, but it's not how people generally move. So if I wanted this more accurate, then I would actually create maybe a record of movements, and then I would change the skin meshes to be something a bit more accurate. So if we go back to here, let's look a bit more around the character. So mirror script here, I've got public variables for the head rotation, etc. And I've made them public, so I can actually change the values right here, which is really convenient. The possible speed that I want, but really I should say how long in time that I want it to take from one place to another. And the fraction of journey, I've just exposed them so you can see them, so that I can see what's happening to understand it. And then if we come down to the camera rig, as it mentions here, we have a couple of different scripts along the way, and it's this script here, the OVR headset emulator script, that controls the OVR manager script, and then the related settings that go alongside this. And that's pretty much it for today's demo. I hope it was interesting. Let me know.